Hi everyone, let's solve this problem. Kth largest element in a stream. You are part of a university admissions office and need to keep track of kth highest test score from applicants in real time. This helps to determine cutoff marks for interviews and admissions dynamically as new applicants submit their scores. You are tasked to implement a class which for a given integer k maintains a stream of test scores and continuously returns the kth highest test score after a new score has been submitted. More specifically, we are looking for kth highest score in the sorted list of all the scores. Let's say for example, you are given k is nothing but kth largest element, and you will be given the initial list, and you have to find the kth largest element. So first largest is 8, second largest is 5, third largest is 4, right? So this is the kth largest element. Kth largest element here is 4. And also when we add a element, we can actually add elements to this particular list. You can keep on adding the elements to this particular list. That means I can add 3 here. They have given us to add 3. Now in this case also, kth largest element would be, after adding 3 it was 4, after adding 5, after adding 5 it is 5, right? Because if you sort this list 2, 3, or let me sort it in the descending order, 8, 5, 5, 4, 3 and 2. This is the sorted list, and if you see, the third largest element is 5. That is the reason the answer is 5. So we can have two solutions here. Initially, let's consider a brute force solution. And the brute force solution is nothing but, first you will sort the list, given list, and find kth largest element. How are you going to do that? If you see the sorted order, you will just return the nums of, if we are like sorting inside the nums, you are going to return k minus 1. And whenever you get a new element, you are going to add to the sorted list. This is going to take big O of n for every element, right? Additional element, it is going to take big O of n time. And also sorting takes big O of n log n time. Initial sorting takes big O of n log n time, and then if you want to insert the element, it is going to take n. So this is kind of going beyond n or n log n. So we have to find a solution better than this. So let's understand by using heaps. So in this case, initially k is 3 and my array is 4, 5, 8, 2, right? Now I'll create a heap, nothing but min heap. So I'll insert 4, I'll insert 5, I'll insert 8. While inserting 2, I'll check if this fits into my list, but this is less than all the elements given so far, so we can ignore it inserting into this. Now we have 4, 5, 8, and in this case you have added all the elements. Then we are going to add 3. So if you consider addition of 3, it's lesser than all these elements. So our answer for this particular heap is 4, because first largest element, second largest element, and third largest element, and k is 3, so we will return 4. and then we are going to add 5. We are going to add 5. So 5 is greater than 4. So I'm going to remove 4 from this and I'm going to add 5. Right? And the kth largest element is 5. And then we are going to add 10. Right? We are going to add 10. We are going to remove 5. So third largest element still is 5. And then I'm going to add 9. 9 is greater than 8, so we are going, we have 5. So I'm going to remove 5 and 9. Now the third largest element is 8. And then I have 4. 4 is lesser than 8, 9, 10, so it does not make any sense. So the third largest element still would be 8. If you see the answer, it is 4, 5, 5, 8, 8. And for the kth largest element insertion, we are not going to return anything. So whenever we add, we are going to return the answer, like kth largest element. So let's try to code this up. So we are going to declare a min heap. Min priority queue. And then we are also having the k. What are we going to do? For every number of nums, we are going to insert the number, and if the size of this min heap is greater than k, we are going to remove the elements which are not needed for further calculations. Done. And we are going to add a element, and again if this min heap dot size is greater than the k value, we are going to remove that element, and towards the end we are going to return the element which is on the top, nothing but the largest. Min heap will always maintain among all 3 elements whichever is the minimum, that is going to be there in the front. So this is how it works. Now let's try to run it. Okay, it should be NQ. Let's run it. Let's submit it. Okay, let's understand the time complexity of this. So in min heaps, addition is big of log n and deletion is also big of log n. So for every element, right, for every element, considering there are n elements, so it will be n into log n insertions or deletions, right? All the entire process itself, like if there are n elements given to us, this entire n element, if we are considering all the elements as n, either we are inserting it or we are deleting it, right? All of them will take log n time, but our heap size is k, so it will take log k time, right? So our solution will be in big of n log k, and the space is k because we have a heap of size k. We are not using more than that. So this is the time and space complexity of this solution. I hope the solution is clear. Thank you.